In this video, Colin Heathfield from Cole Palmer is going to be talking about peristaltic pumps. So, take us away.
Theo, thank you very much for that introduction. Peristaltic what?
Yeah, so peristaltic pump, when would you consider this and what is it?
A peristaltic pump is a very, very basic sort of pump. It's like, the motion is peristalsis. So it's like the esophagus in the human body. Mm-hmm. If you imagine a long tube, you squeeze that tube, you move along and you release it. That's the basis of the motion. And then if you do that several times, you suck things in, move them along the tube and release them.
Right.
So the pump itself is the tube. The motion is a low shear. It is a very gentle motion. This is the tube actually running through a pump head. If you look at that pump down there,
the small one in front of me.
That's it. If you open, the pump head is open.
Yeah.
You can see a tube running through. That's what we call the pump head.
Okay.
So if we come back to here, that is the pump head. That is the tube running through the pump head. What we have is 3 rollers on this particular pump head.
Yeah.
So each roller is coming round and squeezing the tube and moving along and releasing. So you're creating pockets. Here you create a pocket of liquid within the tube. We defined in another presentation the liquid as being anything from water to toothpaste and many variations in between. If we look at how this grabs the liquid and moves it along, and the roller has to roll on the tube to move it along, it's a positive displacement pump. This technology positively displaces or moves one slug of liquid each time. So each rotation of that head moves 3 slugs of liquid. Those 3 slugs of liquid are 1 rotational displacement. The pump is the tube. The head, the pump head, is how we squeeze that tube and move the liquid along it. And then the rest is the control. If we look at the table, we have 2 different sizes of pump on here. But the pump is the tube at the front. We then have the pump head that squeezes the tube, and we have the control system, from basic controls, which is just a variable speed control, which I think is what we've got on that smaller one, to we have process drives, which are computer compatible. We have the same with the smaller units. They're a laboratory scale or a finer scale. We do modular ones, which means you have the pump and motor. These units contain a motor separate to the control, but they are a very, very variable control. If I jump back to the first slide, one of the major advantages of the peristaltic pump is high accuracy and dosing. And this is because we are looking at these small pockets and we can control them very, very accurately. If you are pumping ink to a printer, for example, so within big industrial printing machines, you need specific amounts of ink, and you need to be able to adjust the amount of ink going depending on how fast the printer is running, how much it's calling for.
Yeah.
You can have a peristaltic pump that can pump the ink, can use the tube, so you have colour containment. You don't want to mix your colours till they get to the print head, otherwise you will spoil your effect.
Yeah.
So you have one tube running from a source container to the not bucket, but the sort of tray where the ink sits.
Yeah.
And if the machine speeds up, the pump can react to that as well and speed up, and works very, very well. The rollers, the heads, these are all components of the pump head and affect the way the pump works, but the tube is the pump. These pumps are the fastest growing pump within the positive displacement pump market.
Okay, can these pumps dry run?
Dry running is a very, very interesting concept, and yes, they can. Dry run means to run without any liquid in it. If you have pumps where you have metal-to-metal faces and things like that, no, they can become very damaged. These pumps, one distinct advantage is they can dry run. Because you have a roller reacting on a tube, squeezing a tube, it can do that all day long. There is no issues with metal-to-metal surfaces, there is no issues of unusual heat build-up, so they can dry run. Very, very useful if you wanted to transfer in a chemical environment liquid from a drum to another drum. You can put the pump in and walk away, because when it's finished pumping the liquid across, you don't have to be there to switch it off. You can just come back in a period of time and switch it off, which is very useful because you don't have to have an operator standing there watching it all the time.
Right.
Other technologies, you would have to have the operator constantly there. With that, you don't have to, and it gives you a distinct advantage. That's one of the big areas. One of the other things I didn't mention, another major benefit for these pumps is their low shear. Now, shearing is how the liquid moves against itself, and if you have something that has a low shear requirement, it means it's delicate. If you move it too fast, you damage it.
Right.
The way to describe that is if you had something like a cell culture that you needed to move very gently, so you've grown something, you need to move it to another area to do other things with. If you move that too fast through other types of pump technology, you can bash them. And you bash your cells, you destroy them.
Right.
So if you move it gently, you won't damage it. Another example, I think we spoke in another video about foodstuffs, such as soups and things like that. If you move them gently in a tube, they look the same when they come out as they did when they went in, which a peristaltic pump can do. If you move them too fast or through a rotational pump, something like a centrifugal, you liquidize the lot.
Right.
And if it's a product that you're selling, so your quality of presentation is important in terms of your foodstuffs, then that's a critical point for how it has to turn out. A lot of companies that make ready foods have to pump that to filling trays and things like that, and it affects the quality. It does make a difference.
And what are the maintenance requirements for a peristaltic pump?
This is one of my favourite points, minimal. The wearing component is the tube. It's a consumable, so you will have to change it, but that's the only item. The tubes, we can get up to 10,000 hours life out of certain tubes in certain conditions, which is several years runtime. The motors and the pump heads, I've known them to go on in excess of 10 years, so the actual drive and control gives a very, very good working life, doesn't have any issues. One of the easiest things to say, if you look at the smaller pump, now if you could, it's got a pump head on the front, if you could close that pump head, the maintenance is very easy. My 5-year-old daughter was doing this in the dining room in my house.
Right.
If you now open that pump head,
Yeah.
so move that lever, now remove the tube, just lift it out,
Yeah.
and now put the tube back in.
He
That's
says,
it.
having never done this before.
That's
There
it,
we go.
perfect. No, and close it, close the pump head. Now, you said you've never done that before. You've just done the maintenance for a peristaltic pump.
There we go.
It's as easy as that. My 5-year-old daughter does that. Very, very basic, very, very easy. We have another pump head here, which is called a high performance pump head.
Yeah.
So it's the same thing. You unload, you take out, you would do this, remove the tube, refit another piece of tube. That is your maintenance. So they are very, very low maintenance, very, very easy. And because your process is contained within the tube,
Yeah.
you're not breaking process.
Great.
So again, from a hygienic point of view, you're not letting ingress of the outside inside or the inside to go outside. You're maintaining this hygienic sterility. And you can use them as what we call a single-use system, where you would just take it and throw away. And therefore put a new tube in, and you're clean again, because you can have many different tubes irradiated, many different variations. So it is a wonderful pump. So we're looking at the accuracy you can get, the controlled, we say dispense, because you can have it doing a repeated dispense over a very long period of time. If you wanted to dose into a production line, if you wanted to put some colouring into a foodstuff, into a dog food or something, or just as an example, dog biscuits, different coloured dog biscuits. How do you think the colouring goes into those dog biscuits? And it's literally, you have a long line producing the biscuit goo, whatever it is, and there will be one sort of pump pumping that, and then you want something to feed some colouring into that line. So this will feed it as it's a goo, as it's coming along, and then it's made into a dog biscuit.
Okay.
Goo is the wrong word to use, but
Yes.
as a food stuff.
Yeah.
But, working within the pump industry, we often describe things as certain parameter, certain things, because it helps people to understand what the liquids are. If I said how thick is something, if you say if you put it in a jug and try and pour it out, would it come out? You can describe that, so I then know what the viscosity, etc. is.
Understood. Superb. And what about if you want to increase your process?
Very, very valid point, very good point with the peristaltic pumps, because increasing the process, so increasing the amount you pump or making the process going from lab scale to pilot plant is very, very easy with peristaltic pumps because it's the size of the tube. They're positive displacement, so we just put a bigger tube.
Oh, okay.
Again, if we look at the two pumps on the table,
Yeah.
one has a tube size that's there,
Yep.
if we can see that.
Small one, yep, got it.
And then to do more, you just have a bigger tube.
Sure.
So it's as easy as that. The pumps go in speeds of, we can go from 0.1 RPM up to 600 RPM on the smaller. The larger ones are a lower speed as their top end, because it's about squeezing the tube and then allowing the tube to actually reopen and reform. And if you do it too fast, you wouldn't allow the tube to reopen.
So Colin, is this an evolving pump technology?
Very, very much. I'm very glad you asked the question, a bit Blue Peter-like, but I have something here I prepared earlier.
Right.
This is what we call a tubing sample kit. It's an evolving technology because the secret of this pump is the tube. The pump is the tube. If you look down here, there is a range of different pump tubings. They can handle different liquids. Some are more hygienic rated than others. They are approved to pharmaceutical grades, to food grades.
Yeah.
Some can handle chemicals. And this is something we can hand out to people to show the different tubes and the tubing compatibilities and the sizes of tubes we can go to. We're not limited by these. We have many, many different options within our range. We have stainless steel drives.
Yeah.
We have bigger pumps. We have the BT range, which is up to a much larger ID tube, can go up to 45 litres per minute. We have modular units, which is very, very useful in a process environment or a lab scale environment if you want to put the drive and pump in a fume cupboard or a fume hood to do something that's a little more dangerous, but you can have the control outside so you can operate it with your hands rather than having to cloak up each time you want to adjust something in the fume cupboard.
Right.
So we have options where you can remove the danger from the operator by having the operator external to where the more dangerous part is.
Understood.
Or if you looked at a more dirty environment where you don't want to constantly put your hands into the muck, you can have the pump down doing the work where you want it, but you can have the control up on the wall. And it makes it much easier. And that control, again, can be linked into a computer, can give feedback, so it can be remote operation. There are many developments within this sort of theatre, but the core thing is the tubing. And we are constantly developing new tubings. And each time we develop a new tube, it's effectively a new pump.
Right.
That we can squeeze with the pump heads and work in a different way and control with all our software.
Understood. So is there a summary of peristaltic pumps?
Yes. I think if we were to summarise them, strengths are, as a positive displacement pump, a very good flow range. The liquid containment within the tube. The tube is the pump, the liquid chamber, the seamlessness of the chamber. These are just strengths that I can't emphasise enough. They can suction lift, they can dry run. A suction lift is to actually lift the liquid from a height.
Yep.
And these can do a very, very good suction lift. If you were to put your cup of tea out the window, down on the ground level, and we're on the first level, you could drop the tube into the pump and suck your cup of tea up from ground level up to your desk.
Right.
It's that sort of suction lift we can offer. It's very, very good. The chemical compatibility we covered with the different types of tubing, from ones for solvents to ones for just water. And then on a very specialist or a more specialist area, you have the hygienic and the shear sensitive. You have the very accurate dosing. So from the food stuff example I said, to pharmaceutical, to additions, to process. So a lot of it is behind the scenes work that people don't realise happens to the products they use, because these products are made up of a mixture, and these add that mixture, or to a basic filling application. If you were just filling tubes from a putting glycerine in bottles or something like that, you can have it so it does that, and it puts an exact repeatable dose in there. So it's a very, very useful type of pump.
Great stuff. So, thank you very much.
Thank you very much.
Colin Heathfield from Cole Palmer on peristaltic pumps.